Hey everybody, this is part 2 of our last lessons 10-5 on rectangles, part 2. Alright, so we left off at number 7, alright, and then we had a picture of this rectangle, and in each rectangle we learned at the part 1 of the video, all of these are right angles, and the diagonals are equal, and then all the other properties of parallelogram are the same. So, we look at what they gave us, 37 degrees for angle 1. They want us to find angle 2. Well, that's an easy one. 90 minus 37 is what? 53. Okay? So I have 53 right here. Label as we go. Now they want us to look for angle 3. And there's several correct ways to find this out. Okay? The way my brain wrapped around it is I found these other angles first. Meaning, if this is 53, these are parallel lines cut by a transversal, then I know this is 53, which is alternate interior. And if this is 37, then this is 37. Now, this is what is cool with a rectangle. All right, as I'm getting to number 3. I know that if my diagonals are equal and they bisect each other, then all of these sides are also equal. And we end up having 4 little triangles here. 1, 2, 3, 4, however you want to count them. And they're isosceles. So if this is 37 as 4, which already gave us this answer here, number 9, angle 4 is 37 degrees, then angle 3 is also 37 degrees. Okay? Once again, isosceles triangles have 2 sides that are equal, and their 2 base angles are equal. Okay? Now, to find out angle 5, all right, it's an easy way to figure this one out. This is exactly the same concept. We have another triangle over here. And just like I promised, we had 4 isosceles triangles. Here's another one right here and here. So if these 2 sides are equal, these 2 base angles are equal. So angle 5 is 53 degrees. Okay? Angle 6. All right? As I look at this triangle right here, I have 37. I just redrew it. This is K, J, and then was this E or nothing? Whatever this is right here, that's okay. 37 plus 37, and we're finding angle 6. So angle 6 equals, well, there's a couple ways. The easiest way to look at this is how many degrees are in every triangle? 180. 180 minus 74 is my answer. Okay? So angle 6 is 106. I kind of got tongue twisted because I would have said angle 6, x plus 37 equals 180. Same deal. Okay? Now, 7, you can do it using this triangle over here, or you can just say, golly gee willikers, I'm on a straight line here. Okay? So if this is 106, I know a straight line adds up to 180, and so that has to be 74. Okay? So that's it. The other way, if we twist this triangle, and however way you want to look at it, 53 and 53 is 106. All right, and then that left us for 74 up here. So a little confusing on my small picture, but the math is not too bad at all. Okay, now we go to the next one, all right, which is a big picture that I don't have the technology for. If this thing's continue, I just kept thinking we're going to be back to school. Blah blah blah, and Mrs. Elner, like you guys know, has a beautiful camera, but I'm looking at this coordinate proof. All right, so all we have to do, and I shouldn't say all because it's a lot of work. It's not hard work, but it's kind of a pain, I understand. In a rectangle, not only do we have to prove that the 2 sides are congruent, okay, but what made the rectangle different than the other parallelograms is the diagonals are congruent. So Mrs. Zellner was super cool with our notes here, and she said BG and LH were both radical 5s. So that's good. These 2 sides here and here are equal. I know you guys can't read this probably. These other 2 distance was radical 45 and radical 45. Great. So we know it's a parallelogram, but do we know it's a rectangle? No. So how do we do that? We find the diagonals. Okay? So the diagonals for this rectangle are GL, sorry honey, okay, GL is one of our rectangles. I believe it goes in that direction there, all right, G to L, and then B to H goes in that direction. That means we're at 5 minutes?
Yep.
Okay, I don't like to go too long, guys. Distance equals. Okay, now, you guys do not have to do it my way, but I write x1, y1, x2, y2, so I can easily plug it in. It just makes life easier for me. So -1 minus a -2 squared. Watch your signs, okay? Y2 is -3 minus 4 squared. All right, so -1 plus 2 becomes 1 squared. And I know I don't like to do this either. Mrs. Elner go wild if you didn't put the square root in there. -3 minus 4, okay, is what? -7 squared. So essentially we have 1 plus 49. The distance is radical 50. The distance for GL. All right? So rewind it, see what I did. The biggest thing is watch your signs, label these. It shouldn't be a problem. It is easy to make a mistake though. Distance for the second one is, and you should rewrite it every time. I'm just trying to save you guys a little bit of time. Square root of x2, so 1 minus a -4 squared. Oh, darn it. Now, the big thing here is these plus and minus signs. Make sure you're just careful that we're subtracting those. And I'm looking at y2, so that's going to be -2 minus 3. Sorry, guys. So -2 minus 3 is -5 squared. Okay? 1 plus 4 is 5 squared. All right, so I tried to write that as quick as I can so you guys could see that. 5 times 5 is 25. Now be careful on your calculators. A negative, you got to put in parentheses, but you are also going to get 25. So the distance of BH equals radical 50. Okay? We are not done, but they are definitely equal. And if you don't get them equal, that's okay. That just means it wouldn't be a rectangle, but I would double check my math like you can see in that chicken scratch there. So to make this question perfect, all right, and I know sometimes this drives me a little nuts in geometry, all right, we need to make a statement. BGHL is a rectangle because not only are both pairs of opposite sides congruent, because not only are both pairs of opposite sides congruent, so are its diagonals. Okay, or something to that effect. Mrs. Zellner has a handier way. Diagonals are congruent, opposite sides are congruent, it's a rectangle. Okay, that needs to be that mace. All right, last piece of this is the next one. You guys don't have to sit here watching me do the distance formula again. Okay, but once again, as I do the distance formula 6 times, you can see the work is right here. You guys should practice it, especially if you're struggling with it. JK, the distance, should be radical 45. ML should be radical 45. JM should be radical 20. KL should be radical 20. Those are the opposite sides. And then your diagonals, JL comes out as radical 65. And MK comes out at radical 65. So, prove that JKLM is a triangle. Or a triangle. Prove that JKLM is a rectangle. JKLM, okay? And again, you write it out. JKLM has both pairs of opposite sides are congruent. And make it simpler than what I wrote before. And its diagonals are congruent. Okay? So all of the same terminologies. Opposite sides are congruent. and its diagonals are congruent. So there you have it. What are we at, about 10 minutes?
Yeah, 10 minutes.
Macy's arms are getting tired. So homework 5 should be pretty easy, and then we'll have that posted up for you by Friday. Okay, everybody, stay safe, be smart, enjoy the weather, and keep working hard. We only got a couple weeks left, and then hopefully we can get back to business in September. Have a great day.